Okay, scale factors with area of a triangle. So I've given you a bit of a formula here, and what this is saying is the area of triangle ABC is equal to the area of triangle EGF multiplied by some scale factor. Okay? So, before we even go anywhere, we've just done scale factors. In order to get area of EGF, is EGF the larger or smaller triangle by looking at it? Larger, right? This side is 9, the corresponding side is only 3. Therefore, we've got a larger triangle. So, to start off right away, this scale factor, this K, is it going to be greater than 1 or less than 1 if we need to multiply by the larger area to get a smaller area? Oscar? Less than 1. We're going from a larger triangle to a smaller triangle, so we must be using a scale factor that's going to be less than 1. Okay? This is how we can relate areas to other triangles. The same thing can be said, I can rewrite this to say the opposite. I could say area of triangle ABC times some scale factor. This is a different scale factor, okay, the other one, squared is equal to area of triangle EGF. So in other words, depending on which scale factor, we use it to multiply those areas, okay, because remember, we can find 2 scale factors for every pair of triangles. With that being said, what we're going to do here is we're going to find the scale factor between the larger triangle and the smaller one. So we're using the same things as before. We have 9 over 3 as corresponding sides. 5 over, this is G and this is E. 5 over G. Oh, is that right, what I've done? It should be G over 5. Right? Remember, we always have to line up the same triangles. And E over 4. So we've set up our ratio. And we know when we divide one of the ratios, we're going to get a scale factor. So we'll divide our 9 over 3, and our scale factor will be 3. Well, since 3 is greater than 1, that means we're going from the smaller triangle times this scale factor we found to get to the larger triangle. Great. That works out perfectly for us because we can easily find the area of this triangle. We cannot easily find the area of this triangle because we only have one value. Okay, so let's find the area of the first triangle. It's a right angle triangle, so area of a triangle is your base times your height times 1/2, or divided by 2, however you want to begin. Our base is 4, our height is 3. So we get 4 by 3 times 1/2. 4 by 3 is 12 times 1/2 is 6. So 6 units, because I didn't give it anything, 6 units squared. That's the area of our ABC. Okay? Well, triangle ABC is 6 units, and we need to find the area of triangle EGF. Instead of going through the scale factors, finding E, and then putting that through the exact same formula, as soon as I find the scale factor, and I have the area of the first one, I'm going to multiply by that scale factor squared. Well, since the scale factor is, scale factor is 3 here. Okay. We're going to replace the K with 3, being our scale factor, and we're going to get 6 times 3 squared is equal to the area of the other triangle, EGF. Okay? Well, what's 3 squared? 6 times 9? 54, there we go. 54 units, okay? So, the area of the other triangle is 52 units squared. Let's check this. This is the fast way to do it, but we're smart enough that we know we can check our answer by using that same scale. Well, the only piece of information we really need is E. We already have the height. Let's find the base. We know the scale factor is what number? 3. So if the base of the other triangle is 4, what's the base of this triangle? 12. So let's take that information. If we'd done it the old-fashioned way, the area of the triangle, what do they call old-fashioned? What is it, 9 and 12? Our base was 9, sorry, our height was 9, our base was 12, and we got to multiply by 1/2. What's it going to be? Should be 108.
54.
9 times 12 should be 108. Times 1/2. 54. So, we ended up with the right numbers, but instead we didn't actually have to go through the entire process of finding another side and then plugging it in. As soon as we found the scale factor and had the area of one triangle, we plugged it into that formula, and boom, we got the area of the other similar triangle. Okay? That's just a small formula you guys can remember.